All right, so here's another application problem dealing with linear functions. Um, in this case, it doesn't really tell you it's linear, so we're going to go over why it's linear, and it doesn't give you an equation, but we're going to use point slope formula, and hopefully you'll understand why. So the question says a rock's dropped from the top of a 2,000-foot building. After 1 second, the rock is traveling 32 feet per second. So we have 1 second, 32 feet per second. After 3 seconds, the rock is traveling 96 feet per second. So there's a change here. Let y be the rate of descent. So that's the decrease in height. X is going to be the number of seconds since the rock was dropped. So we're given info here. We're kind of given a freebie. Part A says write a linear equation that relates the time to the rate. So here we go. We have 2 points. So this is saying if x is seconds and y is descent or height, those are our points. So after 1 second, it is traveling 32 feet per second, so it's decreasing 32 feet. Our second point is going to say 3 seconds, and now we're traveling 96 feet per second. So we're going to use these points to write an equation. All right, so let's find the slope first. So m, we're going to do 96 minus 32, and then 3 minus 1. I'm not using parentheses because nothing's negative. So even if I put them in there, which I'll do now, it's not going to change our math. The negatives are where people start to really make some silly mistakes. So this is 64 divided by 2. So 32. That's our slope. So now that we have our slope, we can write our equation. So we have y minus, let's use our first point, y minus 32 equals our slope, which is 32, times x minus 1. So again, we're using this first point, x1 and y1, to plug in and find that. So we can distribute y minus 32 equals 32x minus 32. Add 32 to both sides. Y equals 32x. So there is our equation. And that's relating the time to the rate. So pretty much if x is time, every time that changes, every 1 second, the rate of decrease, how fast it's changing, is increasing by 32. So part B is asking, use the equation to determine the rate of travel of the rock 10 seconds after it's dropped. So after 1 second, it's 32. After 2 seconds, it's 64. After 3 seconds, it's 96. You can find any of this by plugging in x values. So they're saying if it's 10 seconds and x is the number of seconds, they're saying what is the answer when x is 10. So all you have to do is plug it in. 32 times 10, so you get 320. And that's the rate of travel. So look at the units. All these y's are feet per second, feet per second. It's a rate of descent. So this is feet per second. And that would be your answer for part B. So hopefully this helps and you understand how to set up these problems and go from there.